All right, class, just like we did in class for one of the examples, we're going to do this problem here. We're going to try and figure out how far away this point is from this plane. So I got a drawing here, something like this. So here's our plane, and we don't know where this vector is located. So just drawing it in here somewhere, and we don't know where this point is located, but we know that this point is well, I guess it could be, well, no, it can't be, because here if I put 0, 0, 0, it's definitely not in this plane. It's somewhere away from this plane, so I'm just going to draw it up here somewhere in space. So we're going to figure out how far away this point is. And it turns out there's a formula, which we showed in class, that if I can figure out a vector that goes from this plane, and it's easy if I just started at this drawing, if I start right here, if I can figure out this vector that goes from the plane to the point, and then what I can do is I can translate it onto this normal vector, which is given by this vector right here. I can translate it onto that normal vector, and then I can find the distance of this. So what we did in class was we took this vector, I'm just going to call it the green vector, and we dotted that with n. So this blue vector we'll call n. We dotted it with n, and then if you divide that by the magnitude of n, turns out that that would be this straight line distance from this point down to the plane. Okay, so the math is actually pretty easy. All we have to do is try and figure out this green point. We've got to try and figure out a point on this vector. Well, that's pretty easy too. All you have to do is pick an x and y, or I actually picked the z value. I'm going to do that. So you're just going to pick a z value and a y value of 0. And then you can solve that for the x. So if I pick a z value of 0 and a y value of 0, I get 8 times x minus 4 times 0, right? I'm just putting in this equation, plus, so this skipped ahead a little bit here, but plus z value of 0, that equals 8. So this cancels off, so I have 8 times x equals 8. Well, x then must equal 1. So now I have my point right here. That point is 1, 0, 0. Now what we're going to do is take this point and find the vector from this point to the red point. Well, that vector is easy. As I go from 1, 0, 0 to 0, 0, 0, okay, terminal minus initial, I'm going to get negative 1, 0, 0. So that's that vector, and then I want my normal vector, which is just going to be 8. It's this one right here. 8, negative 4, 1. So 8, negative 4, 1. And then we're going to divide that by the magnitude of this vector. So first we'll do the dot product. We get 8 plus 0 plus 0. It's actually negative 8, but that's the opposite value, so it's 8 over, what's the magnitude of this vector? Well, that's 64 plus 16 plus 1. Okay, turns out that's 81, and then we want the magnitude, so we're going to take the square root. So 8 divided by the square root of 81, which is 9. This is your distance. That's all it is. So this got a little sloppy. It stopped halfway. I hope this showed up. This is your formula. The green vector dotted with this normal vector divided by the magnitude. And in our case, we got 8/9.